Hello, welcome everyone's back to this channel, which has got more than 160 videos so far. Continue to increase the number of videos. So if you want to take advantage of watched all those videos, it's time now to subscribe this channel so you don't miss any latest update just by clicking the bell button. Thank you for that. All right, today we're using the vectors calculus to do a projectile motion. So we know the projectile motion. We're going to just revise a few things. The vector IT, which is called the position vector, is the integration of the velocity vector with respect to t. So then the velocity vector is the integration of acceleration vector. All right, so that's the equation we're going to use. So that's two. We're going to, so this question giving you a couple of things. One is the G, which is the gravity. And also we have a velocity of initial speed. So initial speed means the velocity when the time to zero, the magnitude is given as 30 meters per second. So that's given. So we need to find so there's a wall away from the beginning point. This is initial point, 7 meters away from the beginning horizontally. So the wall with the 10 meters tall, that's the wall. So we're going to find out whether that ball will passing this wall without hitting that wall, whether it's above or whether it just will be below the wall. So we need to find that distance. So that distance, the vertical distance, we call Vx or Vy. So this is the Vx. Sorry, I'm going to use red. So the velocity when the x component is 70. So we need to find what is the velocity of the y component. Sorry, not a velocity, it's the position vector equal to what? So this is the position vector of the x. All right, so now, so we also know is the position vector is, we have an x component, so we call Vx I plus position vector Vy with respect to time. So we all got those position vectors in two different dimensions. So we call x and y dimension. So let's find those dimensions first. So we know the velocity, initial speed is 30. So therefore, initial velocity will be using the x component, which is 30 times by cosine. So this is the x component of initial velocity. We call Vx 0. That's Vy 0. All right, that's 30 times by sine 60. So we initial velocity. And also we know the gravity is opposite to, because the projectile motion is vertical. So therefore, it's a negative 0. That's gravity's go down 9.8 in the vertical direction. So therefore, dv dt is 9.8 J. So therefore, my Vt will be integrated negative 9.8 with respect to time. Sorry. So therefore, it's a negative 9.8 T plus C. So now we're going to decide what a C is. So we plug V0 into the left-hand side at T equal to 0. So therefore, C is this. So that's the initial velocity. So therefore, we put it back into the velocity formula. X component is unchanged. And the Y component is the vertical 30 times by sine 36 degree minus negative 9.8 T. So that's a velocity function. So velocity vector function is dr dt. So RT is integration over VT. So we integrated every one of them. So the first one is 30 cosine 36 degree times by T. Next one will be 30 sine 36 degree T, and the next one is half of 9.8, which is 4.9 T squared, which in the J component. So that's a component, vertical component. So now we're going to find out what is the C again. So we plug 0 when the position time equal to 0 and the position is 0 because the projectile starts from 0. So C is 0. So therefore, my position vector, we have got an X component and a Y component. So the X component of a position vector, we're given as a 70. So that's the given condition. So therefore, the X component equal to X component. So we work out how long takes the projectile, the particle fly horizontally 70 meters. So 70 divided by that is approximately 2.88 seconds. So now then we work out a vertical component of the position vector. The vertical component we call y. Substitute 2.88 into the vertical component, which is this is the vertical component. So plug 2.88 to the function. So we got 10.1 meters. So that's just above 10 meters. So therefore, the ball should be cleared the wall. So will not hit that wall or below that wall. That's it. We solved that projectile motion by using two different components of the position vector. Thanks for watching. If you enjoyed the video, please give us the thumbs up. And I'll see you in the next video. Bye.